Welcome to today's webinar, our regularly short webinar about the most frequently asked questions answered by Dlubal support team. My name is Andreas Herold. I am responsible for marketing and public relations in the company Dlubal Software. For instance, the Dlubal website, the German and English webinars, newsletters, customer projects, and so on. I've been working for 13 years now in the company. I will be the presenter today, and my colleague Markus will support me. And he can introduce himself.
Hello, my name is Markus Baumgartel. I am responsible for customer support and frequently asked questions on our website. And today I will help my colleague Andreas to answer your questions during this webinar.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. So sorry, I had to adjust a little bit. So for the attendees who participate the first time, you can ask questions during the webinar. There is a control panel on the right side of your screen. You can show that with that arrow here, and then you can enter a question here. Markus will answer you. If you don't get an answer during the webinar because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email questions to info@dlubal.com. Okay, then we start with the first model and the first question. And the first question is, how can I use guidelines to create a grid for a building? That is a quite new feature. A lot of users have been waiting for it, and we implemented it under guide objects. Here left at the bottom, you can see the guide objects in the navigator data, and then here the guidelines. With a right click, you can create a new guideline, and this dialog is opened. You can select the coordinate system. That's the normal global axis system in my case. Then the work plane. The work plane should be XY in my case. You can enter an offset. Then you have to define the type parallel to X. I will start with that guidelines. Then you can also create an offset. We will do that with the second and the other guidelines. Then you can select the guideline number or a user-defined guideline or a user-defined label. You can lock the guideline position, that you can move it by accident also, and you can glue the nodes for manipulations. When you move the guideline, the glued node will be moved as well. So, okay, we start with the first guideline. We call it A, parallel to X, and we start with an offset 0, apply, and you can see in the RFEM window that is the first guideline created. We activate it, and then we copy the guideline, and we have to change the offset. Let's measure the distance between the two columns here. Okay, 18 meters, and we have to rename the guideline. Apply. Okay, then we create the other guidelines, the same workflow, 36 meters, and we rename the guideline. Apply. So, and then the last guideline, I change only the offset and the name. Okay, so all the guidelines in X direction are created. Now you can see the distance between the name of the guideline and the node is very far. You can change that. For example, when you change the grid, here by a right click, you can press edit, or I leave the dialog and show where you can find it as well under tools and work at the top, tools, work plane, grid snap, and so on. Okay, then you can enter distances here, 15 plus and 15 minus in X direction, in this direction. And for example, 70 and 10 in Y direction. I apply. And you can see the name has been moved in the near of the node. You can also check dynamically according to size of model. Let's do that. And you can see that the number of the grid points are created automatically. Now let's create the last guideline in Y direction. I create a new guideline parallel to Y, offset 0 and a user-defined name. I name it 1. Apply that. Now all is okay. So, no, this one is not correct. Okay, now you can move or copy or delete all the lines here or certain lines. Okay, now our guidelines are created. Just an example. So then we turn to the next model and the next question. Next question is, I came across the area of load application setting in the load wizard. How does this setting affect the magnitude of the load in my model? So this is a load that has been created with the load wizard. I double click on it. You can see that dialog. And how you can create such a load, I will show that. At first, you have to select in the base data here left at the top under add-ons the load wizard that must be activated, but this is a default setting. The combination wizard and the load wizard are selected by default. Okay, and then here on the left side at the top, insert, there are the load wizards. There are different load wizards. Member load from area load wizards, for example. This is the load that I created before, what you can see in the model. There are also the snow load wizard and the wind load wizard, for example, and our two wizards. Okay, I double click on, or let's display it separately. Now with a right click, I can display the loads separately. So, and now I double click on the load. So, and I open the dialog. And under geometry, you can see this setting, fully closed plane. The complete, where there's, for example, a plate or the trapezoidal sheet over the members, and all members gets a load. and the wind can affects of the full area here. So, and if you want to that only the members get a load, only this small area, then you have to select empty on members only. We can see that at the moment the vertical and the diagonals gets a load about 1 kilonewton per meter, and if I apply that, you can see that the load is or has been decreased. Only the members are affected by a wind load. So, and if you, for example, change that member, at the moment the width is 10 centimeters or 100 millimeters, and if I rotate the section, for example 90 degrees, you can see the load has been decreased from 0.1 as for this diagonal, and now it's only the half of this value. Okay, that's the setting. I changed that back, or I press undo, and you can see now the load is 0.1 or about 0.1. And I do another change. Imagine that, for example, a trapezoidal sheet spans from the lower beam to the upper beam, and only these beams are affected by the load or supports the trapezoidal sheet. Then you can remove the influence from members parallel to straight members. Number, I select all the 3 members, and all members that are parallel to these 3 members don't get a load. Let's try that. Fully closed plane. Okay. So, and now that's the effect when a trapezoidal sheet spans from the lower to the upper horizontal beam. Okay, let's turn to the next model and the next question. A surface model, a concrete slab from a building, for example. And the question is, can I get the program to calculate the spring of a wall for line support with modeling the wall at the same time? In an earlier webinar, we showed a similar function or similar feature for the nodal supports. Let's double click on this nodal support. And when I press the Edit button, you can see where is selected stiffness via fixtures column. And when I turn to this dialog, I can, the model is supported by elastic surface foundation, elastic nodal support, and so on. You can enter dimensions, the height, and so on. Then if the column head is hinged or semi-rigid, and when you change that, the values for the springs are changing. Okay, so I leave the dialog, and we have got a similar function for the line supports. I double click on the line support and edit all the used line supports. Now then you have to check the stiffness via fixtures wall. In the previous, in the preview, you can see the walls already. So then you can enter a thickness of the wall, a wall height. Then also if the wall head is hinged or rigid. Also for the wall base. You can enter a material, I'll leave the concrete material as it is at the moment. And you can see, as I mentioned in the preview, the considered wall. Okay, and now you can see also springs for the line supports here. And this can avoid or smooth singularities in the FE calculation. That's the adventure. Okay, that should be all to this question and to this model. We turn to the next model and the next question. And the next question is, how can I create multiple FE elements across the thickness of elongated thin solids without having to create an extremely fine FE mesh? At the moment, you can see a steel plate here with a thickness of 20 millimeters. I can go to the FE mesh settings. The FE mesh size is 2 centimeters. 20 millimeters. That's the thickness of the steel plate. And you can see for the width and the length, the size of the FE mesh is quite okay, but not for the height. There's only one FE mesh. You can see that in the results. You can see there's only one FE element, and the results in that case, what is selected, the equivalent stresses, the sigma V mises, and that's not okay. For your information, under calculate, you can find the result smoothing, and at the moment there is no smoothing. You can see that here, constant on mesh elements. Those are the real results without smoothing. That looks quite better. But those are the real results, the constant on mesh elements. So I double click on that point here to get in the dialog from the solid. Double click. Another possibility would be to go on the left side and the navigator data at the bottom, then open the solids. There's only one solid. You can double click on it or right click and edit, and the same dialog has been opened. So then mesh refinement I selected, and there is a quite new feature, the layered mesh. And if you activate it and select one area or one surface, then the opposite surface has been selected automatically by the program. And you can see that in the graphic, you can define a number of finite element layers. So, and I increased it to 4, at least 4 or 5 mesh or FE elements should be for one distance here, in that case for the height or for the thickness. Okay, I applied it. Okay, let's create here at the top. We'll generate the mesh. Okay, and now you can see where are 4 elements or 4 layers for the thickness. So let's calculate all again. Okay, that looks quite good. Where are 4 elements in the height, and the results are better than before. Let's go through the solid with here on the guide objects with a clipping plane. I activate any plane here, or okay, so, and now you can go through the solid and you can see the results are quite good, or good to evaluate. Okay, that's all for this model and for this question. And the next question is, how do I customize the appearance of objects in the background? So you can, for example, select only the concrete cores or concrete cores. So left at the bottom, you can go to the views and then activate the visibilities and the concrete surfaces. And you can see the hidden objects are quite good to see, but a lot of users ask, how can I modify the transparency? So how to do that? Yeah, you can, of course, completely do that invisible with that function here, show hidden objects in background. You can deselect that and you can see the deselected objects. So, and let's change or modify the transparency under at the top, under options. You can go to the program options, and under settings, you can find that setting here, intensity of interactive objects. Now you can increase the number here, apply, and you can see the changes. Okay, a quite, I think, important feature, because sometimes it's annoying when you see all the deselected elements and so on. Okay, so then we turn to the last question for today. I turn back to the first model, the bus station. I display the results. Yeah, the deformation is okay. So, and the question is, in the model space of RFEM 6, I can aggregate the deformation according to a factor. How can I do the same in the graphic printout? Or rather, how can I adapt the same factor of the display from the model? So I select the control panel, or I display it, and you can change the number here, the deformation factor. You can increase it or decrease it. And the question is, how can I do that in the printout report? So let's print that graphic in the printout report. Here left the both. You can find the feature print graphics to printout report. So, and under the default setting is that, and you can select the display factor and the static analysis in that case here, because it's the deformation from the static analysis. So, and you can increase the number as well, and you can see the change in the preview here. So then we can press save and show, and we can see the graphic in the printout report. And you can change or modify that graphic afterwards as well. So let's do that. I do a right click on the left side, then properties, or at first I press edit. Okay, then you turn back to RFEM, and for example, you can change the view, right at the top, for example, in X direction. Okay. So then it should be updated in some seconds. Okay, and you can also change the properties. For example, the deformation factor. Okay, so and the graphic should be updated. Okay, now I think a quite good hint. Okay, yeah, that's all for today's webinar. I turn back to my PowerPoint slide. Yeah, if you want to book a free online appointment, such as a free product demonstration on non-binding offer, just contact our sales team with that link here, or you can scan the QR code. And that would be good if you want to buy the program or an add-on or vision offer and so on. Okay, let's turn to our website that I can show you where you can find the recording and the models. Under dlubal.com and news and events, you find the webinars. That's today's webinar. Those are the webinars for the next week or next weeks. Next week, stress strain analysis, a brief presentation of features. Then the week after next week, member and surface design on timber components in RFEM 6. Yeah, if you are registered for our newsletter, you will get an invitation, or maybe you already got an invitation. I think the invitation should be already sent, at least for this webinar. If not, just click on it and scroll down and register here. So that's today's webinar. In the next days, you will get an email with a link to that page. Also, you will get an attendee certificate, and then you will find the recording here in the middle, and you will find the PowerPoint slide here, and you will find the models here. Okay, yeah, that should be all for today's webinar. Maybe we meet each other in a future webinar. That would be very nice. Maybe last wish when you leave the webinar, there's a small survey, only some questions. You can score the webinar. Just note that the worst score is 1 and the best score is 5. You can enter wishes for future webinars if you want. If not, just enter a sign or leave it empty as you want. That would be very nice. Okay, I wish all a nice rest of the day. Thank you to Markus for answering the questions. Thanks to you for your attendance. Bye-bye.